Hello everyone, welcome back to my channel. So in today's video, I'm going to do a quick demo on how to use ALOHA as well as MARPLOT software in order to do a simple consequence modeling or simple consequence analysis. In this tutorial, I'm going to use these two software to model a dispersion of toxic chemicals, focusing on chlorine gas when there's a loss of containment. All right. This tutorial might be useful to those who are doing QRA, those who are, doing like a HSE, in HSE fields and stuff like that. Okay, without further ado, let's begin. As usual, I'm going to spend a few minutes to talk about, background and introduction to those who don't really familiar with this kind of software. So this software is basically a software that can be used, as I said, to do a consequence modeling. Okay, what is consequence modeling? It is basically a method for you to estimate, the effect when there's a loss of containment involving like a toxic chemicals like chlorine, bromine, ammonia, or maybe flammable gases or flammable hydrocarbon, like for example, gasoline, diesel, propane, butane, stuff like that. And also explosive material. And we'd like to see, okay, when there's a loss of containment, what will be their physical effect in terms of like how big the dispersion, or maybe when we talk about jet fire, or maybe BLEV, BLEVE, boiling liquid expanding vapor explosion. We would like to see how big is the like a explosion radius, or maybe how big is the fireball, and then at each of the radius we'll see what is the energy emitted per square meter. Basically it's a heat radiated, because this will affect, obviously, this will affect all of the asset, maybe human, and anything that are in the vicinity of the incident area. This would be very useful if you do a QRA. QRA is a quantitative risk assessment, where you try to do a systematic method to kind of like quantitatively give uh, you know quantitatively get some of the data with regard to uh, you know with regard to safety. Of course, there are a lot of software, and this software can model a lot of things like overpressure, explosion, toxic dispersion, fire, jet fire, and stuff like that. Okay, one of the things that I like, basically this one, there's a no single best tool that solve all this problem. I took it from this publication by American Society of Safety Engineers. So basically, this paper, what they did was they compiled like 80 commercial or free software that people use to do a QRA, and it involved like a frequency analysis, what else, physical or consequence modeling, and maybe QRA. So what they did was, so one of their conclusion is there are no tools that can do all things. So each tool have their own, advantage and disadvantage. Okay, and if you see on your top right here, there's a trade-off between complexity as well as computation, I would say power. Of course, when you use a empirical model, it's quite simple, quite fast, give you sufficient a quick result. But of course, they might be missing out a few details. But if you want to go like a highly complicated modeling approach, for example, like using CFD model, of course, you can get a lot of details like from like the distribution or dispersion at different locations, for example. I provide two images here, example of consequence modeling software. This one on the left is called FAST software. It's a consequence modeling software developed by DNV. Images here, as you can see, they want to simulate like how much heat is being radiated when they put their flare system at this platform. So they can simulate that, and then maybe they will decide where they're gonna put like a quarter, what is called, where people live, whether this gonna have effect to the equipment or maybe human. And then of course on the next one is called Flex. It's basically a CFD based simulation by Gaxcon Singapore. Of course, if you see the images here, they can do like a very nice computer animation. But of course, you need the AutoCAD to create the 3D plan, and then try to integrate them to the software. Yeah, but of course, this one is a it's a paid or commercial software. But in my case, I'm going to use Aloha because I don't have any money to purchase the license. But to those who are, kind enough to, give to donate a free license to us for especially for teaching, that will be much appreciated. But anyway, yeah, as I said, I'm going to focus on Aloha software. Aloha is an acronym of Area Local of Hazardous Atmosphere. It was developed by US EPA Environmental Protection Energy, as well as NOAA, National Oceanic and Atmospheric Administration. So these two entities, not combine, they just join forces to develop Aloha. So it's basically a hazard modeling program to basically help us manage emergency when there's an emergency. Okay, and it can be used by anyone, to plan and respond when there's exist emergency when emergency occurs. This software, they can model, as I said, toxic gas cloud dispersion, flammable gas cloud, left jet fires, pool fire, vapor cloud explosion, stuff like that. Of course, they can also estimate what is the threat zone. Threat zone is basically red means maybe it's too dangerous, or um, and then maybe orange is medium, kind of dangerous, and then yellow is like probably a low effect, something like that. As you can see here, these are just one of the output of the simulation of the program. It is a very simple program, so you cannot really expect a fancy result. And then on the bottom right here, you will see there's a textbook. I think this textbook by Crowell is very useful if you like to know what is the how should I say this? Um, what is the mechanics, or maybe what are the underlying equation that describe for example, the dispersion of toxic gases. If you want to know, like, what are the equation, what does some of the term used in the software means, I recommend you to read this textbook. If focusing on this tutorial, I recommend you to read chapter 5. You will see there's equation, what are the terms, stability, classes, and then how do they, and by reading this, you can pretty much know, okay, what is exactly meaning behind some of the values you input in the software. So these are Aloha software. And then of course, let's say you want to do analysis on a specific location, right? This threat zone, you can transfer the threat zone into a specific location around the world using a MARPLOT software. It is also a free software. I forgot to mention that this software is quite easy. Just Google US Aloha US EPA. The first result is you click the first result, and then you will see you can download MARPLOT as well as Aloha software. It does not require too much space, download space, like maybe 100 megabyte roughly, or 200, I forgot. So yeah, so for example, here they estimate some kind of like probably a dispersion around this area. I don't know what's this area, but of course, by knowing this, you can pretty much kind of like maybe plan a certain emergency response, or maybe emergency route to those, for example, in the central hospital where they should go and stuff like that. On the right here, I'll just provide like two references for you to read if you like to know about what people do with the software. I mean, it's nothing fancy to be honest with you, but it's a publication if you would like to read. All right. So going to our design problem again. I don't develop my own design from scratch. I refer to this publication. It was published in 2012 by this two or three author. What they do is they do a toxic dispersion of chlorine in Taiwan. Okay. What they do is they just compare number one, two different scenarios. What would be the radius of impact, or maybe what would be the physical effect when the loss of containment occurs at a in spring versus winter, which is a bit quite simple, I would say, but whatever. So what I did was I just extract some of the important information here, and then I put them in this table. But before that, let's discuss what I would like to do today. So what I'm gonna do today is I'm gonna use Aloha software uh, to simulate scale of impact, in a parenthesis a threat zone in the event of toxic chemical release of chlorine. Okay, and after that we're gonna use a MARPLOT software to map the threat zone in the Texas City industrial area. So these are the only thing that are different. So they do it in Taiwan, I'm gonna do it in Texas or Houston, if you will. Now, just a few parameter here. Chemical, we're gonna simulate direct, I would say, release of chlorine around 2,002 ton for 10 minutes with a rate of 0.2 ton per minute. Temperature assuming 29 degrees Celsius, around 80% humidity. Wind is coming from east direction. It was measured in 10 meter, in the height of 10 meter. I will explain why these are important. And then the wind speed is around 1.5 meter per second. Also, cloud is also important parameter that you need to input. I'm going to assume complete cloud cover. There's no inversion stability class. I'm gonna just use whatever recommended stability class based on my input. And then the terrain, I'm just gonna assume urban or forest, and then calculation approach, gonna assume heavy gas dispersion. Okay, just read this paper and then you could understand uh, all of this. But I will explain later in my when I do the demo. All right. So when it comes to determining a threat zone, I'm going to use a default one. So the default one, they use AEGL. So there are three. So the red one, AEGL 3, AEGL 2, AEGL 1. So what does it mean? AEGL is acute exposure guideline level. It was basically for airborne chemical release. It was by the US. It's basically from the US guideline, I would say. Yes, this one is used by emergency planners and responders as a guide when dealing with accidental release of chemical into the air. There's also another kind of like a level of concern or threat uh, what is called threat zone. The other one is ERPG, Emergency Response Planning Guideline, also developed by US, maybe in Malaysia, in the context of Malaysia, or maybe in the context of Thailand, different countries, they probably have a different set of values here. But I give you an example here where level one is just a, green, just a low level where there's no immediate effect on on life. This one's probably moderate. The third one is a life-threatening effect or maybe death. So I'm not going to go into details here, but I'm just gonna, what I'm trying to say is I'm going to use a default one. All right. I think that's pretty much it. So yeah, let's go to our software. All right, this is my desktop. What I'm going to do is I'm just going to find Aloha. So I have Aloha here. Just click. They have a symbol of coconut tree. So this is what you would see. So again, this is a very simple software. Of course, they have their own limitations. So you can read this. Maybe it failed to predict under certain circumstances, but I'm just going to assume that whatever information, because it was published, so I'm just going to assume that whatever they did is correct, right? So yeah, just hit OK. And you will see a text box occurring here. Let me make it bigger. No, probably not. Okay, make it bigger. So this is your menu ribbon. Okay, first thing first, we need to decide what is our site. Okay, site data. So what I will do is I will go to site data. I'm gonna select my location. Since the Texas City is located in Texas, I'm just gonna assume it is occurring. I'm just gonna choose Houston, Texas. But let's say, for example, you decide to use Malaysia, right? Of course, in here there are no Malaysia location like Kuala Lumpur. So what you can do is you can just click add. Let's say you want to add a location outside of the US because this was developed specifically for the US use. So let's say you want to add a location in Malaysia. What you can do is just click add. Now location is, let's say for example, Kuala Lumpur, right? And then they will ask you what is the location. Is it in the US or not? Probably no. Now elevation, let's say, for example, elevation of 10. I don't, this is just a random number, but I'm just going to show you how, if you want to add a new location, you can do that. So let's say 10 meters, right? Latitude and longitude, again, just specify, let's say 10, maybe 10, 0 here, 0. This is just a random number, but this is how we add. Hit OK. And then country name, let's say Malaysia. This one is your time zone. Let's say I say +8, for example. Hit OK. Yeah, so I actually have have added Kuala Lumpur as a location in their library, so I don't have to repeat the same thing. But that's how you, if you want to add a new location, that's the way to add a new location in the software. Hit OK. Okay, I'm gonna cancel everything. So here you just find Houston, H for Houston, Houston, Texas, select, and then click, highlight and then select. Now this will be updated, so no changes whatsoever. After that, go to site data. Just gonna you just specify building type. Although the dispersion occurs outdoor, but this one I'm just gonna use whatever that they recommend here. This is where when okay, even though the dispersion occurs what is called outdoor, they also do a simulation calculation on the dispersion indoor. So I'm just going to assume this single story building, unsheltered surrounding. Okay. Now, date and time, there's no need to change. I'm just going to assume, I'm just going to use whatever default date and time. I'm going to use internal clock, or if you want to have a specific time, you can specify. After that, you go to setup. So first, we need to what is called? We need to specify our chemicals. We're gonna use, okay, they are obviously this is a simple software. They don't have a lot of list of chemicals. They also do solution, but not a lot. Okay, just 1, 2, 3, 4. Maybe you can add. Probably no. I'm not so sure. But pure chemicals. I'm gonna use. I'm gonna find chlorine gas. We're gonna simulate dispersion of chlorine when there's a loss of containment. Chlorine. Okay, I have chlorine here. Click and then hit select. So of course, this one is a chlorine gas case number. So where do they get this information? Actually, they get it from DIPRR design. I don't really remember the design. I don't really remember. P is physical. R don't remember another R also. But this one is a database from AICHE if I'm mistaken. But anyway, okay, there's one way. Let's say you want to add a new chemicals, right? How do you want to do that? So go to setup one more time, go to chemical. You have add button here, click add. Of course, you need to specify chemical name, molecular weight, AEGL, values. This one need to be, you need to input everything. So you need to know the information before you specify the new chemical. Density, boiling point, and stuff like that. So these are all of the stuff that you need to provide. And then you hit next and then see what they require. Okay, anyway, I'm going to cancel. I'm going to assume these are fine. Okay, the next one, you need to specify your atmospheric. Basically, what's your surrounding condition? Okay, okay, SAM station here is basically a station of atmospheric measurement stations, basically kind of like a station to measure your atmosphere. So they have their station. If you have it, maybe you can click this. But oftentimes, I'm just going to use user input because I already know my information. Click use input. Now the wind speed in the design problem, it is 1.5 meter per second. Wind is coming from east, so type E. Okay, or let's say it is neither east, west, south. What's the other one? North, east, south, west, right? So those are for letters, right? But let's say it is the direction is neither. So you can just type angle, 45-degree angle, any angle between 0 and 360. But I'm just going to type E. Now, this wind is 1.5 meter per second, and it is coming from east. And then the measurement of the wind speed is, according to this, is 10-meter height. Now you have one option. This one is called a SAM station. So the wind speed is measured at, if you click this, the height of the SAM station is 3 meters. And if you choose this SAM, as I said, it's a station of atmospheric measurement. This one is kind of like a weather station, so like a tower to measure the weather. So if you click this, the distance is 10 meter, or if you have your own value, just specify any value that you want. So let's say 3, for example, doesn't matter. Now, why this is important? First of all, you have to understand wind. Depending on the height, right? Wind has their own gradient, like no slip zone in water flow in the pipe. So wind, this wind speed is at 3 meters. No, when it's close to the ground, maybe it is much, what is called, much uh, uh, slower because there's a gradient of wind speed. So this is where it's going to be important for you to specify height. Ground roughness, I decided to use urban. Now, cloud cover, in the design, they say complete cover. Now, complete cover is designated by 10. So in the US, in this software, the US, this US EPA, they decide they are 10, kind of like a 10 range, okay, for cloud cover, from 0 to 10. You can specify the number, or you can just simply specify this thing. Clear is 0, complete cover, partly cloud. Now, why this is important? First of all, you have to understand that cloud cover, they affect the solar radiation. So when there's a complete cover, there's going to be a less solar radiation, so they're not going to heat up the earth. So it's like a refrigeration, right? In the refrigeration, you have a cold box on top where the hot gas will be cool on top and then become denser, go down. It will create a circulation, of course. So when there's a circulation, it's gonna affect the dispersion. But let's say you don't really know what any of this mean, so you can just click help button. They will redirect you to their program software. They will give you an examples as well as explanation what does it mean. So this is quite useful. The help button is quite useful for you to understand the meaning of their values here. But of course, you can also refer crowd textbook. It is equally good. Okay, going back to the software, and I'm going to hit OK. Now they're gonna bring you to the option number 2, to the next option. So air temperature is basically 29 degrees Celsius. Stability class, okay, they recommend D. Okay, so I'm just going to accept, but if you would like to override, you can override and then choose whatever. But this is basically, okay, how do they decide this? This is basically based on your input. Please refer Cloud textbook. They will give you a table that explain that describe what is D means. Now, inversion here means, I don't want to talk about this to be honest, but just assume no inversion. Yeah, no, I'm not going to explain about this. Because, okay, you know what? Just a quick one. Inversion is basically there's a layer, as you go in the z-axis, so going up, there's going to be a layer where I also don't remember, but just Google or read textbook. Now, humidity, you can specify wet, medium, between wet and medium and dry. But in this case, they say 80% humidity percentage, and I hit OK. Now you have specified data, site data, chemical, atmospheric data. Now, after the last one is source strength. Basically, what like how potent, I'm not saying how potent, like what is the quantity, how it's being released, those kind of things. So go to setup, go to source. So we're gonna assume a direct release, okay? So if your gas is stored in the container, just hit tank or whatever, and then specify whatever information that required. But in this case, I'm going to assume a direct release. So as I said, it is 2 tons of chlorine being released. In here, let's see, it should be a ton per minute. It should be 0.2 ton per minute for 10 minutes. So it's become, no, it should be 100 minutes. Wait. Yeah, no, 2 ton is 0.2 times 10. Okay, correct. Now, where does it being released? Is it on the ground or is it on top? Okay, so the location where it's being released are also important because those who are, especially gas that are, let's say you release it on the certain height, like maybe 35 meters. Let's say 35 meters. Now, if the gas is much denser, much lighter than air, right? Our surrounding air, obviously it's not going to go down. So if you have a heavy gas, right now, because of their buoyancy there, they will go down, and then after it's being diluted and it becomes more or less the same, then it's gonna go up and then being dispersed, something like that. Okay. So I'm gonna assume it is 35 meters. Now hit OK. Source greater than zero. Okay. Uh, uh, okay. Just say okay. I already forgot what is it. What do they say? Okay, anyway, this is my information. Okay, what to do next? Go to display. Okay, just go click thread zone. Now, these are the thread zone by the default one. But if you want to use a different kind of guidelines, ERPG, PAC, or use a specify, you can specify that. But you're just gonna assume AEGL3. Now hit OK. Now this will pop up as you can see. These are your thread zone where the wind is coming from the east, so go that way. And of course the red one here is the AEGL3 2 and then 1. So the maximum what is it called? The maximum distance is around 10 kilometers. Now, another thing is sometimes it display in what is called English unit, like this one could be in yards, so or miles. So how do you want to change that? It's quite easy. Go to display here, display option. You can change to English unit to metric unit. Now, of course, before I forgot, calculation option, Aloha will, default one, Aloha will decide the calculation option, but in the text, in the, what is it called, in the design problem, they say use a heavy gas dispersion, so click this, hit OK. And then what I'm going to do is probably I'm going to do it again. Thread zone, hit OK. Okay, it's basically the same. Okay, whatever. So this is what you have. Okay, this is basically your thread zone according to for direct chlorine dispersion according to a what is it called? At a certain location, at certain wind speed, certain condition. Okay, and then the thread zone is based on AEGL guideline. All right, next step is how can we plot? Okay, this is just I would say the distribution or the map of dispersion, right? How can you plot them in a specific location? So this is where MARPLOT takes will be used. Okay, so I will find MARPLOT, MARPLOT. Click the software. It's also a free software, by the way. So you will have something like this. Yeah. So this is basically a location. You can zoom in, zoom out. Okay, this one. No, sorry, not this one. So you can make it bigger. Now this one, you have a different kind of maps. So you can use Google Earth, Google Satellite, SD Street, physical. You can choose anywhere. So they give you like a different representation of the area. So this is basically a Houston area. This is probably a Galveston, Texas. This around there, like 2 hours from Houston. This is where I live for 4 years during my PhD studies, but whatever. Okay, yeah, this actually satellites basically the actual, I would say, satellite images of the location. So this is the Texas City Industrial Complex. As you can see, this is probably a tank, you know, a tank farm where they store something, I don't know. But in this case, let's use S3 physical, what is it called? S3 physical uh, 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 base map. Okay, they give you this appearance. If you use S3 street, they become like this. So, okay, whatever. Now, I'm going to make this one a bit, I'm going to hide this one so that it become bigger. Now, so I'm going to zoom out, maybe a bit. All right. Now, in here, what you if you how do you want to import the thread zone to here is quite easy. Go to this option, click uh, set thread point at click point, click. Oh, sorry. Uh, Set source point. Uh, okay, now there it is. Now this is the dispersion of the toxic gases in Texas City Industrial Complex if 2 tons of chlorine being dispersed with wind speed around 1.5 meter per second coming from east. Okay, as you can see here, the yellow zone is quite large. It's around 10 kilometers or something. So this one could be those living in here could be in a life-threatening effect. So they need to be evacuated as quickly as possible. So based on this, you can evaluate them from different perspective, maybe in terms of like what is the emergency route, what is the best route, okay, who need priority the most, and then who's gonna be evacuated next and stuff like that. Uh, Also, you can also talks about like their probabilities. Maybe you want to combine like frequency analysis or stuff like that. I don't know probabilities, and I don't know. I'm not really an expert on this HSC, but to those who expert, maybe they know how to further utilize this data. I think that's pretty much it about the software. So yeah, let's go back to our slides to conclude. All right, everyone, as you can see, this is basically a print screen of whatever we did earlier. So as you can see, this one I did it like a couple of days ago, so the location is not really the same. But you get you get my intention, right? So in this one, the one on your top left here, this is basically the map coming from the Aloha itself. This one is the map or radius of effects, radius of threat zone. If you specify a location, and this one can be done using a MARPLOT. I don't know why I got 7.5. Maybe I specified in I like the one that I did a couple of days ago. I specified slightly differently, but whatever. You got what I mean. All right. Okay. I think that will be all for me. If you like the video, give it a thumbs up. Consider subscribing for my channel to my channel, and I'll see you guys in the next video. All right. Bye bye, and have a nice day.